All right, so even function is going to go on the left side. And Jonathan, can you give me an example of an even function? All right, x squared, that's one. Nia, can you give me another example of an even? Okay. And somebody give me a really creative even function. All right, I like it. 256. What's an even function?
Anything with an even number.
Even power, right? Okay. All right, you guys noticed a couple things. The first was symmetry. Alex Miller, where's the symmetry for an even function? Symmetry about the y-axis. All right, and that's graphically how we can tell. Brandon, what is the identity you guys came up with algebraically? F of negative x is equal to what? When you put in a negative and you square it, what comes out, a negative or a positive? All the time. All right, so algebraically, this is how we approach it. Then you're going to need to know that, especially if you don't have a graphing calculator. So we're going to be able to go ahead and graph this and connect this concept, and this is going to have to do with reading the math, which I think will help make sense of this a little bit more, especially the relationship between the graph and the algebra. So let's say we have x, and we have negative x, and this is f of x, and here is f of negative x. Graphical transformations. What happens when you drop a negative inside the argument? What type of transformation is that?
A flip.
It's a what type of flip? It's inside the argument. It's horizontal. Isn't this being flipped horizontally? Aren't we flipping this? That's why this point ends up right here. Okay? That's even. Now let's look at odd. And I know some of you guys didn't finish odd, so I'll finish it with you. Were you clapping, Daniel? Nice. I'm glad you appreciated it. All right. Alex, give me an example of an odd function. Alex Roscoe, since we have like 7 Alexes. Don't think about it too hard, man. What's an example of an odd function? Here's evens. Squared, fourth.
Just like x to like first.
Love it. Perfect. Sarah. It's another odd. X to the 5th. And then who's got a really creative one?
X to the 1473.
That works.
That works. It's odd. All right. And what will be true of that is, in the symmetry here, some of you guys notice you can actually cut it like this way. It's like the line y equals negative x. But we're going to call this symmetric about the origin. And we'll talk about why that is when I graph it. And I don't know if anybody got to this identity because of time. What'd you guys get, Kelsey? Perfect. It's actually f of negative x equals f of negative x. But don't write this in quite yet. Because when you cube a negative, what do you get?
Negative.
A negative. The negative we're actually going to move out here. And we're going to do that for kind of teaching reasons and to also see the relationship in the graph. So we're going to just put the negative on the outside. Okay, same thing, we still get a negative answer. Now how does this look graphically? I know some of you guys got a couple of these graphed. We'll graph a cubic. Alright. So there's your cubic. We have our x and we have our negative x. And now we have our f of x. This is negative x. Okay, oops. Negative f of negative x. Okay, now I kind of want to show you something because I think it will help with the thing about the flips. The reason we call this the origin is if we look at our transformations, I think this will be easier to see it this way. You have two flips going on. What type of flip is this?
Horizontal.
Horizontal, and this is vertical. This group was talking about it up here, that there's actually two flips going on. If you look at it, we are flipping it horizontally, right, to get to here, and then we flip it vertically to get down here. So there's actually two flips, and that's why you see these two different parts. Okay. I got one example before you guys leave. I'm going to have to keep you like a minute or two in. Sorry, here it is. Because this is going to be important for your quiz. Determine if the function is odd, even, or you could have a third category, neither. Sometimes it's not one or the other. Now, where this becomes tricky is if I don't let you use a graphing calculator and you don't know what the graph looks like, and you have to use algebra to solve, and that's the case of this one. 2x cubed plus sine of x. You know what each of these graphs look separately, but together you don't know what they look like. So if we go back to what we did with the algebra, and think about your table, when you made your table, what did we plug in on each one for our simplified form? We plugged in a negative, right? So our end goal is when we plug in a negative, are we going to get a positive answer, or are we going to get a negative answer? If it's positive, or if it's the same thing, it's even. If it's the opposite, it's odd. If it's neither, then it's neither. So we're going to plug in a negative x. We're going to do the same test you did earlier. Now it's just a little bit more complex. You guys can do this first one. Go ahead and simplify that with your team. What happens when you cube that negative? Still negative. So we're just going to bring it to the front. Negative 2x cubed. And now we have sine of negative x. Sine is x or y? On your unit circle? Y. If you have a negative y value, you're just flipping it, so you'll get minus sine of x. And then I'm going to do something which might seem a little strange, but it's for teaching reasons. You'll see why I do this in a sec. Pull out the negative. Go ahead and factor the inside. You should get 2x cubed plus sine of x. Now, let's look at this. Let's compare. Look at this, and look at our original. Are these two the same?
Yes.
Okay. The only difference is what? There's a negative in front. So it's going to help if we actually write it in this form at the end so you can see it. F of negative x equals negative f of x. Talk with your team. Is this even or odd? It's odd, right?
Does that have to do with also because the exponent?
Very good question. I want to answer that in a sec. Some of you could have left it here, because if you look at this, isn't this form just the opposite of this one? Why would I pull out the negative, though, as a teacher?
So you can show us that.
Can you see it actually being pulled out? Yeah. But you can leave it here. Now, Sarah asked a really good question. I want to answer this right now.